guys, how all are you? Hope all are good and fine and doing great in their coding journey. My name is Kunal Singh, co-founder of Admotech. Welcome to my YouTube channel Admotech. Let's start our today lecture, which is based on the type of queue. And later on, we discuss about what is queue data structure and what is stack data structures. We also discuss about many lectures. So stay tuned with me and also follow my regular lectures for your basic improvement in coding in DSA. So let's start our folder and DSA. So here we move in the VS Code editor as we later discuss about. Now firstly we discuss about what is data structure mainly and what is algorithm we define, and in lecture 2 we discuss about asymptotic relationships and also know that what is omega notation and what is theta notation and what is big O notation, and also we discuss master theorem in that. And now in lecture 3 we discuss about binary search, merge sort, quick sort, and these basic matrix multiplication theorems and Karatsuba algorithm. Also we discuss in fourth lecture stack data structures, and also in this we discuss about queue data structures. Now it's times to discuss about the types of queue data structures, which is of four types, which is circular, and also we explain you everything. So I write it in lecture 6.java extension. This is basically the boilerplate which is available in opening the we have a new file of Java. So it's not required in this. Only we use comment tag to justify each and everything of types of queue data structures. So firstly we know about what is basically the queue data structures. Queue data structures is in programming is similar to the tickets queue outside a cinema hall, where the first person which come first serve first. So it follows the principle of FIFO, that is first in and first out. It is nothing other confusable because it's simple, as we already seen in that which persons come first will serve first. So it is basically related to our real life world problem. So now we discuss about the types of queue data structures. It's all about four data structures. Now we discuss each and every part, that is first of all we discuss about simple queue, and then we move further forward by knowing about circular, and then we move into priority queue, and then we move about double-ended queue. And basically in first of all we take queue data structure, simple queue data structure. In this it is simply follow the principle of FIFO, that is first in and first out. And also in this queue, in simple queue data structures, we see that the insertion is enabled by the rear function and the removal of the function is enabled by the front function, that we earlier discussed in our lectures. Due to this nature, it strictly follow the rules principle of FIFO, that is first in and first out. So I also write in this. And the removal of take place in front function. So this is simply how we discuss about how simple queue data structures can run. And now we discuss about the circular queue data structures, which is the most important. because in circular data structure the last element points to the first element, making a circular link that is connected in circular way. By also we discuss about that how these examples run by taking an example how these queues are also run in next lecture. So subscribe my YouTube channel to get notified about my new lectures. So I write this definition also for your reference. And coming soon my website is launching for your reference notes, so please go through my website and takes all the notes that I discuss in my lectures. So stay tuned with me. In simply way that we know about that what is basically a circular queue data structure. The last element points to the first element, making a circular link. As it is simply by joining by all the points by connected in a circular format. And now we discuss about I gave a gap for each and everyone so that no coherency can occur while reading the notes. So we discuss about the what is basically a priority queue data structure. In this, we give the priority of we check every element priority in the queue so that when higher priority occur, it shows first, and then if lower priority elements can occur in the last, so that and if there is the priority of two elements coincides, then it shows both of them. And now we simply discuss in a gradual format way. A priority queue is a simple type of queue in which each element is associated with a priority and is served according to its priority. If elements with the same priority occur, they are served according to their order in the queue. That I simply say that which priority gives first the ability to show, then first it shows, and which priorities become the least, it shows in the last. I write it in. So this is the priority queue data structure. That is, a priority is a simple, special type of queue in which each element is associated with a priority and is served according to its priority. And if each element with the same priority occurred, they served according to their order in place of queue. And now we discuss about the most important thing in the priority queue data structure, that is insertion occur based on the arrival of the value and removal occur based on the on priority. Means the arrival of values is basically insertion allotted and then removal occurred on available on its priority. That I simply write it in flowchart manner, that insertion based on the arrival of the value and removal based on the priority of the element value. So you understand what is basically the priority data queue data structure. It is simply based on the priority level. And now the last but not the least is double and queue data queue. So it is simply we say that in double-ended queue, insertion and removal of elements can be performed from either of the front or rear. Thus, it does not follow the principle of FIFO. So we understand that all the types does not follow the principle of FIFO, that is first in and first out. In this double-ended queue, we inserted anything by using the front and rear. We also take the example for this for better clearance. and also you know that how these statements run in a queue data structure. Also this is happened because for the removal of some disadvantage and in our previous DQ data structure, because its time complexity is not come out to be constant. So in order to find out the constant time complexity and space complexity, this comes in this way, so that accessness of code is easily available and it is quickly shown by the compiler. So I also write the nice definition for double and q, so that you know that what I actually say about q, double and q. So guys, I write the definition of double and queue. In a double-ended queue, insertion and removal of elements can be performed from either from the front or rear. Thus, it does not follow the principle of FIFO, but it has some advantage that you see later, and that we run the code for this example, and you also understand that but why this not follow the principle of FIFO, because it is somehow different, as you see in my lectures also. And this is the overall lecture for today now. And in this lecture we discuss about the types of queue data structures, and later on we discuss each and every queue by giving an proper example for better understanding, and for better clearance, so that you cannot hurdle in solving the problems. So that guys, subscribe my YouTube channel for getting the new lectures, and also like me, comment me, and subscribe my YouTube channel to your friends and share with your friend. Thanks guys for your love.